Oh, nice.
Can I have H2O because I don't know
When you're maybe when you're all done, neon, beautiful. All right. So the reason it's important to know is this is how they hook together. Now, every single element really wants to be like this guy. This is neon. And if you notice this line on your chart, these purple ones all the way down, these ones are called the noble gases. They're noble because they stay apart from everybody. Like the kings and the queens, they don't go hang out with the peasants. These guys don't go hang out with other people or other elements. Ta-da! H2O. Close. Because all of their electron spots are filled, they don't have to share with other elements, with other pieces. So if we look at oxygen here, she did an H2O. I'm going to do a little bit more complicated H2O. See this oxygen here? He's got room for two electrons, right? That aren't filled. See hydrogen here? Your H? He's got room for one electron. And he has one electron. So he's going to come here and share this electron. It's oxygen. I'm bad at this game. So they're gonna share this oxygen, this electron here. We're gonna share electrons here. You can eat that guy. We're gonna share this electron, and then we're gonna have another hydrogen. You may eat yours. Okay. So you're gonna have another hydrogen. And he's going to come, and he's going to hook himself on over here because he wants another electron too, right? So they just kind of hook themselves up together so that everybody can have 8 electrons all together. So this guy, he would want something that can give 3, right?
Mine would need something that would give 3 more.
So he could join up with boron because boron's got 3. He could join up with 3 hydrogens. Right? He could join up with something that has 2. He could join up with 3 lithiums. And so that's how chemistry works, is the elements go and they join together. How many he needs? He just needs 1. So he would probably like to have a hydrogen or a lithium.
Helium.
Fluorine lithium. Fluorine lithium is.
Helium.
Yeah. So that's basically why chemistry works. That's how all of these things join together. And it gets complicated because you get whole big long chains of elements hooking together. One of the ones that reacts the most with stuff is your carbon atom here. It can have 4. So you get long chains of carbons, carbon, hydrogen attached to it here. And most of your foods, animals, and people are made from whole bunches of carbons hooked together with other elements. Pretty cool? Okay. What you got here? 3, you got an H3O. How did you do that? Because he only has room for 2. That would be really weird chemistry going on there. Okay, we have to move on or we're not going to get through everything, so.
Can I hook one with this?
You may hook, sure. You can hook whatever you want, but if you can. Is that one yours, the beryllium?
Well, I already ate one.
It's fine. If they're not going to make you sick, you can have them. Now, where did the chlorine and the sodium? I've got the sodium. Do you have the chlorine?
Yes.
I just want to tell you one other thing about when elements hook together. And that involves the sodium element and the chlorine element. Okay, guys, go sit down so everybody can see. And eat your marshmallows. Go on. Hey, you want to bring your chlorine element up here? Who knows what sodium does? Sodium. Okay, I'll just show you. Sodium is here on this first row. And they have these, you know how they're all different colors? That's because they do things similar. Like these purple ones, they're all ones that are noble gases that don't join with anything, right? This first row are called alkali metals. And they have something that they do in common, which is kind of fun, but there's no way I could demonstrate it here. And that is if you get them wet, they explode.
What? Any of them?
Any of the ones in this first row besides hydrogen. Lithium, sodium. Well, yeah, hydrogen isn't part of this group. That's why it's a different color. But if you get any of these ones in this first row wet, these alkali metals, they explode. So if you can go home and check on YouTube and search alkali metal explosion experiments, you can probably find some really good stuff. Okay, over here on this side, we've got chlorine, which is a poisonous gas.
Oh, let's drink some.
Yeah, don't drink it, okay? So, but when elements join together and they start sharing electrons, I'm gonna stick this sodium onto your chloride there. It changes how they react with things. Do you guys know what sodium chloride is? Have you ever heard of sodium chloride?
Yes.
What is sodium chloride?
I don't know, but I've heard of it.
You've heard of it. Well, you're putting together this thing that explodes in water and this poisonous gas into one molecule, and you know what it makes?
What?
Table salt.
Table salt?
Table salt that you eat on your French fries.
So if I add
What?
water
That's
on
kind of
these,
weird.
so you can actually do that?
No, it won't explode because when they join together, it changes how they react. It changes what it's like. Is that weird?
It's weird. It's
So
a
that's
lot.
part of chemistry, is that when things add together, it changes. You want some sodium chloride? This is better tasting sodium chloride than salt. So it changes how they react. And most of chemistry is learning how these things join together and how they react. Okay? Now, no more marshmallows. Okay, don't want you to get sick. We'll never forgive you if I let you eat marshmallows and you get sick.
It's my nose.
Okay, we gotta hurry here.
Sophie, look at my big.
So, going on to the next thing, we're going to discuss acids and bases. Acids and bases are a pretty important part of chemistry. Do you guys know what acids are?
Yeah.
Yeah, they kind of
burn.
burn things, yeah. And do you know what bases are? No? A base is kind of like the opposite of an acid. Okay.
So if they join, they go.
Sort of. Where did my vinegar go? How many of you guys have seen a vinegar volcano? Yeah? Is that fun?
Yeah.
Who here hasn't seen a vinegar volcano? Never seen a vinegar? Okay, well,
What if this joins with this?
I would have to look it up and see, one, if it's possible, and two, if it would work. Okay, so I got here some vinegar. This is an acid. Okay. And we have here some baking soda, which is a base. Now I'm going to start out by saying that acids and bases always react together to neutralize, to try and get to the middle so that they're not an acid or a base anymore. So you mix an acid and a base and they go towards the middle to be neutral. Water is neutral.
So these.
Straight water, it is plain and neutral. And not all acids and bases react together exactly the same way. They just, oh, we want to make a volcano, let's make it red.
Yeah.
My twins made me try it with all of the colors to make sure every color of volcano would work. But, okay, so we're taking this acid. Okay, you ready?
Yeah.
Some of you know what's going to happen. Those of you who've never seen a vinegar volcano, you ready?
It's scary. Lava. Let's make it.
That's not, it probably tastes pretty yucky because it's got vinegar. Except for, remember how I said that they're neutralizing each other? You're taking the one that's an acid and the one that's a base and they neutralize. This combination here is mostly water. You know
Well,
what?
it's not paint.
Can I leave?
Smells disgusting.
I'm gonna smell it.
Oh no,
What do you need?
I left one of my other experiments at home.
That's sad.
It's sad because I need it. It's my
Did
exothermic
you just
experiment.
tell about
I can tell you about it.
Okay.
But
You're right. It does
it
smell
makes,
like paint.
this makes mostly water. And my other experiment, the reason I thought of it is because you can take, and the instructions are on your papers I gave you, you can take vinegar and baking soda and mix them together very, very, very slowly so they don't blow up like that. And then you cook it so the water goes off. Okay, and it leaves behind my other experiment that I didn't bring with me. So I will tell you about that when I get to the next part. But that's acids and bases. Now, I mentioned that acids and bases don't always react the same way. They don't always explode like that. And what if you want to know if something's an acid or something's a base? There's ways to tell without mixing them together to see if they explode. And they have what they call indicators. And I made some indicator juice.
It's milk.
Actually, it's not.
What?
Ew.
It looks like blue.
It's kind of a bluish purple. This is really, actually really easy to make. What does it smell like?
I can't smell anything.
You can't smell. You smell it over there? What does it smell like to you? No?
Vinegar?
You know what it is actually?
No.
It's cabbage. It's red cabbage. You could if you want. You just take some red cabbage